Hi everyone. To the people who are new here, I'm Rahul, and to the returning subscribers, welcome back. This is the sixth video of the EKS series, and in this video, we are going to be learning about one of the coolest and my favorite Kubernetes feature, which is called Karpenter. Don't worry if you have never heard about Karpenter before, because in this video, I'll explain everything that you need to know to get started with Karpenter. So let's get started. But before that, if you have not subscribed to the channel yet, please consider subscribing. So let's get started. Alright, to start learning Karpenter, we have to first learn a few Kubernetes components, one of them being horizontal pod autoscaler. So what is an HPA? It is a feature that automatically increases or decreases the number of pods in a deployments, replica sets, stateful sets to match the current demand of the application. Let's see an example here. Suppose we have a node here, and inside this we have a deployment running with 3 pods. And for this we have configured an HPA, and it has been told that anytime the memory crosses the 70% criteria, please increase the number of pods. So now suppose the memory crosses the 70% criteria that we have set, and a new pod is needed to handle the load. But due to some reason there's no capacity left on the node, because nodes are basically physical or virtual machines who have a limited number of resources. You just cannot infinitely increase the number of nodes on that. And to do so, what it will do is it will trigger something called node autoscaler. Now what is a node autoscaler? Well, node autoscaler is a Kubernetes component which checks for pending unscheduled nodes and increases the number of nodes to accommodate new pods. So suppose we had a deployment running with 3 pods, and somebody just spin up a new pod, and because there are no nodes left, what it will do is the node autoscaler, it will just create a new node for this pod, and then this pod can be scheduled on this new node, and this is how the scaling works. So talking about the node autoscalers, there are two types of node autoscalers. One of them is the cluster autoscaler, which we have already seen in the previous video. So if you have not seen the previous video, I'll recommend you to go and watch that video, because there I have explained about the cluster autoscaler in detail. And in this video, we are going to be learning about Karpenter. So what is Karpenter? Karpenter is an open source, high performance Kubernetes cluster autoscaler that automatically provisions and deprovisions EC2 instances based on the demand from the application. So let's see some of the features of the Karpenter. First of one of them being right size scheduling. Karpenter continuously watches for pods that are unscheduled. It checks the specific requirements of the pod, including memory, CPU, storage, etc., and then provisions the right size EC2 instances to meet the workload demand. Let's see an example here. Suppose we have an unscheduled pod. Okay, what it will do is it will just trigger the kube scheduler, because kube scheduler is a Kubernetes component which is responsible for scheduling the pod. Kube scheduler will try to schedule this pod in one of the nodes, but then it will see that there are no nodes present in the cluster right now. So what it will do is it will just trigger the Karpenter. Karpenter will check the requirement of the pod, which are mentioned here. So suppose this pod needs some amount of memory and CPU. Karpenter will just analyze this requirement here, and then it will spin up a new EC2 instances based on the requirement, and then this pod can be scheduled here. And let's see the second feature, which is called faster scaling. Unlike node groups, Karpenter directly interacts with EC2 API to launch instance, thereby making the scaling process faster. So if you have seen the previous video, I have explained about cluster autoscaler. So what cluster autoscaler do is it just interacts with the auto scaling groups, and then the auto scaling groups interact with the EC2 API, and then it spins up a new instance, and then that new instance joins the node group, which is a lengthy process. Like it takes 2 or 3 minutes for it to happen, but Karpenter does it in a more efficient way. What Karpenter does is Karpenter just skips the cluster autoscaler, the auto scaling groups, and it directly interacts with the EC2 API and then launches an EC2 instance. Let's see the third feature, which is called cost optimization. It intelligently selects the most cost-effective instance types, including leveraging cost instance with minimum operational overhead. Karpenter looks at the pod specification and then provisions the best instance type depending on the requirement, which we just saw right here. Okay, and let's see the fourth feature, which is simple configuration. It just needs node pools to manage the node provisioning and auto scaling, unlike the node groups where we have to just create a hell lot of resources and then we have to manage them. So let's see what is a node pool, because I just mentioned that Karpenter just needs node pools. So what is a node pool? A node pool is a Kubernetes custom resource definition that defines the constraints for node provisioning, such as instance types, architectures, operating systems, and capacity types. If you just look at this specification, it will be easy for you to understand. So this is a node pool where we define the type of architecture that our node must have. So if you are aware of the CPU architectures, there are mainly two types, the AMD 64 and ARM 64. So here we can define what type of node do we want. Do we want an ARM 64 or AMD 64? Then we can also select the operating system of the instance that Karpenter should launch. It could be Linux or Windows. Then we can also select the capacity type, which could be the spot instances or the on-demand instances. We can select the instance category, which is the most important requirement, because AWS provides a lot of instance types. It could be C type, M type, if you have launched T type. So here you can define the type of instance that you want Karpenter to consider when launching a new instance. Then apart from this, you can also define the node class ref here, and apart from this you can also define the disruption budget, and it basically tells Karpenter when to launch a new instance and when to scale in the instance. So suppose there are a number of pods which are running on a node, and all of a sudden the load from the application is gone, and now we need to scale in the application, okay, because now the load is not that much. So you can define and tell Karpenter when and how to delete the EC2 instances. That is done using the disruption here. Let's see what are EC2 node classes. EC2 node classes are another CRD that defines AWS specific configuration for nodes such as IAM role, subnets, and security groups. Example links to an IAM role and specifies an Amazon 2023 AMI. So if you see this specification here, you will understand what is an EC2 node class. In EC2 node class, we basically define the type of AMI that Karpenter should use when launching an EC2 instance, and we also need to select the role which will be used by these nodes which the Karpenter creates. Apart from that, we can also tell Karpenter in which subnet we want our nodes to be launched, and apart from that, what security groups these nodes should use. So this is all about Karpenter. Now what we'll do is we'll just head over to AWS instance and see how we can install Karpenter in an EKS cluster and how does it work. Alright, so I'm in my AWS console and I have a cluster already running here. And how did I create this cluster? Well, if you want to know, I'll suggest you to go and watch the second video of the series where I've explained how to create an EKS cluster using CloudFormation and also manually using AWS Management Console. So what I'll do is I'll just head over to my EC2 instance and I'll just connect to my Kubernetes cluster using this EC2 instance that was created as a part of CloudFormation template. I'll just click on connect and I'll connect using the session manager. Alright, so I'm connected to my instance. Now I'll just switch to the root user. Now I'm going to be running my commands as a root user, and if you are following this series, you will know that I need to run a command before interacting with my Kubernetes cluster, and that command is AWS EKS update kubeconfig. Region is going to be AP South 1 because that's where my EKS cluster is running, and I have to provide the name of my cluster, which is prod. Alright, so it says a new context has been added to the kubeconfig file. Now I can just add an alias here because it makes our life easier. And now I can run the command kubectl get nodes, and you will see that we have 2 nodes provisioned in this EKS cluster. So now let's get started. So to continue, what I'll do is I'll head over to the GitHub repository which was created for this course, and I'll open this folder called Karpenter. Okay, so I've mentioned about all the concepts in this file called concepts.md. If you want, you can just go and check it out. But what I'll do is I'll just open this file which is called install.md, where I've mentioned all the instructions. Okay, so let's follow the instructions which are mentioned in the nodes. First of all, what we need to do is we need to create a file called trustpolicy.json. So what I'll do is I'll just copy the content here and I will make a few modifications which are needed. And the first modification that is needed is I need to provide the ARN of my identity provider here. So what I'll do is I'll just head over to my AWS console and I'll open IAM console. Here I'll head over to identity providers and select this IAM identity provider which was created as a part of CloudFormation template. I'll copy the ARN and I'll replace this ARN here. Okay, looks good to me. Now what I'll do is I'll just copy this provider here. By the way, we have done this step quite a few times in this series, so now by this time I think everybody must be aware of this. Okay, I'll paste it here and I'll paste it here as well. Alright, it's done. Now I'll just copy this entire script. I'll head over to my kubectl server, create a new file called, what was the name of the file? You can just name it anything, but it's for the ease you can just name it trustpolicy.json. Okay, let's create a file called trustpolicy.json and I'll paste this content here. Let's see what we need to do next. Okay, so now we need to run this command. I'll have to modify the file name because I named the file as trustpolicy.json. So I'll just remove this part which says controller, and now I'll run this command and it says the role is created and this is the ARN of the role which was created for us. Now let's see what we need to do next. Now we need to create a permission policy, and this permission policy will be used by the controller which will be installed for Karpenter. So I'll just copy this entire command. You don't need to make any modifications here because it's just a bunch of permission. Oh wait, you need to put your cluster ARN here, and you also need to put the role of the node groups here. So what I'll do is I'll just again paste it here and I'll put the node group role here. So for that I'll have to go to my EC2 instance. I have to go to instances and I'll open one of the nodes which is created for this cluster, and I'll just use the IAM role which was used for it. So I'll just open it. I'll just copy this ARN from here and I'll paste it here. Okay, so it's done, and now I'll paste the EKS cluster ARN here. So I'll head over to my cluster. I'll copy the cluster ARN from here and I'll paste it here. Okay, so this part is done. Now I'll copy this entire script. I'll head over to my cluster and my kubectl server. I'll create a new file called permission policy.json and I'll paste this entire permission here. Okay, so this is done. Now we need to attach this policy to the role that we created early, and how we can do that by running this command. Alright, but before that I need to modify the file name because I named this file called as permission policy.json. Okay, I'll run this command and then okay, so I got an error and it says there's an error because there's a syntax error in my policy. Let's see where we have the syntax error here. I'll just open permission policy.json I don't see an error here. Oh yeah, I think I saw the error. I missed a few commas. So I'll put a comma here and I'll put a comma here as well. Now it looks good. I'll run the command again. Okay, so the policy is attached to our role. And how you can verify that? Well, all you need to do is you just need to go to your IAM, say the role that we created, and our role is called Karpenter controller, I think. Yeah, this is the role that we created. This is the trust policy which we created earlier, and here we have the permissions. All right, let's see what we need to do next. So after this, what we need to do is we need to install Karpenter. Okay, and how can we do that? Well, we will be using Helm for this. So I'll just copy this entire command, I'll paste it in my notes, and I'll make a few modifications before I can run this command there. So if you see here, I have to put the cluster name, and my EKS cluster name is prod, and what I need to do here is I need to put the Karpenter controller role ARN. And role name is, this is my role which I created. I think I just need to put the Karpenter controller role and not the ARN. So I'll just copy this role from here and I'll put it here. Alright, do we need any other modifications? Doesn't seem like. So let's run this command one by one. First I'll export this value there. Okay, this is done, and now I'll run this command. Okay, so it says the Karpenter controller is deployed. Let's see. Kubectl get pods, and it will be installed in kube system namespace. And you can see Karpenter is running, and we have an error here. Let's see what is the error. Crash loop back off. All right, not something that I was expecting, but still, let's see. Request ARN is invalid. Okay, so I think I messed up. Here I was supposed to put the ARN, not the Karpenter controller role name. At least that's what the message says here. So what I'll do is I'll just copy the ARN now, which is this in my case. I'll put it here and I'll copy this command again. Before that, I need to delete the Helm chart that we installed earlier. And how you can do that? Helm uninstall. Let me first see the name of the chart. It's called Karpenter. What I'll do is now I'll just uninstall it. Alright, so it's uninstalled. Now what I'll do is I'll just run this command again. Alright, so it's installed. I'll check the pods in kube system namespace and see if we have any errors. No, this time we don't have any errors, and now our Karpenter pods are running, which means we have successfully installed the Karpenter controller. Let's see what we need to do next. Alright, so now what we need to do is we need to tag our security groups and subnets. So if you see the earlier part of the video, I was explaining that we need to tell Karpenter which security groups and which subnets to use. So what I'll do is I'll just copy this command, I'll paste it in my notes, and I'll modify the subnet name here so that I use the subnets which are used by my Kubernetes cluster. So I'll head over to networking and I'll copy this subnet name from here. It will definitely be different for you. I think I did not copy it correctly. I'll copy the another subnet. Alright, this is done. I'll just copy it, but instead of this cluster name, what I'll do is I'll just put the cluster name of my EKS cluster, which is prod. Now I'll copy this entire command, head over to my kubectl server, and I'll paste it here. Alright, so it says that my subnets have been tagged, and let's verify this. Let's head over to one of these subnets and see if we have this tag here. I'll just head over to tags, and you can see we have this tag here, karpenter.sh/discovery. Now Karpenter can recognize this subnet and it can launch EC2 instances here. Now what we need to do is we need to tag the security group as well. So just copy this command, the second one, paste it here, and now you need to provide the name of your security group, and which in my case is gonna be this one, the additional security group. Just copy this. By the way, if you created this cluster using the CloudFormation template which was provided in the GitHub repository, you will have all this already configured. Okay, no need to worry about that. My bad. Okay, now I'll modify the cluster name. I'll paste it again. Alright, so it's been tagged now. Let's see what is the next step now. Find the optimized AMIs for your region. So this is an AWS SSMM feature which lets you know the IAM profile or the EC2 IAMI that is available for your region, and it differs from region to region. That is the reason you have to just run this command and just modify the region part here so that you can find the optimized AMI for your specific region. But I don't need to do this because I have already run this command and I've already found out. But still, just to show you, what I'll do is I'll just run this command here. I'll clear the terminal, I'll paste it here, and you see it's giving me an AMI which is specifically used for AP South 1 region. Okay, you can run this command for your region as well. Just make sure that you just modify this region part here. Okay, so now what we will do is we'll create EC2 node class and EC2 node pools. Okay, so if you watch the previous part of the video, I explained what a node pool is and what is an EC2 node class. So I'll just copy this entirely. Okay, you don't need to modify anything here because everything is already pre-configured. Oh no, again I need to give my cluster name here, my bad. So I'll copy it, I'll paste it here, and I'll give the cluster name, which in my case is prod. Alright, I'll copy this entire YAML content. I'll create a new file called nodepool.yaml and I'll paste it here. Okay, looks good to me. Okay, let's apply this file using kubectl. Apply. Okay, so it says the node pools and EC2 node classes are created. Let's see. Kubectl get node pool, and we have a node pool here which is not in a ready state due to some reason. Let's see why not. And to troubleshoot, what I've done is I've written a few commands here. You can just run this command. Let's just run this command and see what is the error here, because it should be in a ready state for it to work. It says no node class is equals to false. I don't see any specific region here. Okay, let it be. Let's see what is the other CRD which was created here. And the other CRD which was created was node class. It says it doesn't have a resource called node class. It's definitely something else. I just forgot. Okay, it's called EC2 node class. My bad. All right. Let's just check the class using get command, and it says it is unknown, so we are not sure whether it's ready or not. We can know it just by creating a new deployment here. All right, so I think we have successfully installed Karpenter here. Now what we'll do is we'll create a new deployment here so that our node autoscaler will get triggered and it will spin up new nodes for the pods to be provisioned. So right now if I see kubectl get pods, you'll see that there are no pods running in my cluster. And if you see the number of nodes, you'll see that there are only 2 nodes running. What I'll do is I'll create a deployment with at least 100 replicas, which means the deployment will run 100 pods, and to accommodate those 100 pods will new nodes. Okay, so let's run this command kubectl create deployment test app. Let's keep the image name as nginx, our favorite image, and for replicas we'll keep it as 100. Okay, so it says the deployment is created. Now let's see the number of pods. Some of them must be in pending state, obviously, because we do not have enough nodes in this cluster. Let's run this command again, and some of them are running, but some of them are still in pending state because there aren't enough nodes in this cluster. So now let's check the logs of the Karpenter controller and see. And how you can do that? Well, you can just run this command. It says there are no node pools found. All right. Okay, I think I found the error, and the error is right here. Role created for EC2 nodes or Karpenter or EKS. Okay, so if you see here, I forgot to replace the role name. Okay, here I have to put the role name of my EKS node groups. So what I'll do is I'll just stop it. I'll just delete all the resources which were created using this np.yaml. First of all, let me just scale down the replica to 0. Scale deployment, test app, and for time being I'll set the replicas count to 0. Okay, so that deployment has scaled, which means we do not need any pods now. Okay, so there are no pods. Now what I'll do is I'll just delete all the CRDs which were created using np.yaml file. Okay, so the node classes and the node pools have been deleted. Now I'll just modify this command or kind of rectify this command. So what I need to do is I need to just copy the ARN of this prod EKS node group role. I don't think we need the ARN, we just need this role name, so I'll just copy this role name here. I'll paste it here. Now I'll again copy this entire script. I'll head over to np.yaml. I'll delete everything, paste it again, and now I'll apply this file. Okay, so it says node pool and EC2 node classes have been created. Let's see if it's in a ready state now. Yeah, as you can see, now it's in a ready state. Okay, so now what we need to do is we'll again just scale our deployment to run at least 100 pods, and for this replicas I'll just set 100. Okay, so it says the deployment has been scaled. Let's see the number of pods. Okay, so some of the pods are running and some of them are in container creating state, but some of them are still pending because we do not have enough nodes here. Let's see the logs of the Karpenter controller. Okay, so here are the logs. These are just the old logs, you can just ignore them. So you can see here registered a node claim. And what is a node claim? Well, if you want to learn about node claim, what you can do is you can just go back to this previous file which is called concepts.md, and I've mentioned about the node claim here. Yeah, it's right here. A CRD representing a request for a new node. So whenever the kube scheduler finds a pod which is unschedulable because of the unavailability of the nodes, what it will do is it will just trigger Karpenter controller, and then Karpenter controller will just create a node claim and call the EC2 API so that it can request for a new node. Okay, let's see. So we have this pod here. Let me just stop this logs and see the number if we have new node which has spun up here. Yes, as you can see we have a new node here which was just launched 52 seconds ago, and you can see it from the EC2 console as well. Just head over to EC2. Okay, so if you see we have a new node spun up here and its type is m@ai.xlarge, which is quite a big node. Okay, but why did Karpenter create this big node? Because the requirement was for 100 pods, and if you just head back to this file here and if you see the node pools, we mentioned that we specifically want the nodes of this instance family C, M and R, and that's what Karpenter did. Karpenter launched a pod from the M family. Okay, now what I'll do is I'll just scale the deployment. Okay, I don't want 100 pods now, I want maybe like 20 pods. So what I'll do is I'll just scale the deployment to run 20 pods, and you will see how Karpenter will just delete this EC2 instance and then it will create a new EC2 instance to meet the requirement. So instead of 20 or 0, what I'll do is I'll just make it 20, and now it says that the deployment has been scaled. Check the number of pods. Okay, some of the pods are terminating now. We'll have to wait for a few seconds. Meanwhile, we can check the logs of the Karpenter controller. Okay, these are the old one. Okay, no need to worry about them. So after waiting for a few minutes, you will know that the number of nodes have been reduced, or at least the instance type of this node has been changed, because Karpenter will try to reconcile this entire configuration. So that was it. That was all about Karpenter, and I hope you enjoyed this video. And if you want to learn about Karpenter more, what I have done is I have mentioned the official documentation link here, which you can get from here. So just click on this and open the official links. This is the Karpenter page. You have every information here that you need to get started with Karpenter. I hope you learned something from this video, and if you did, please share it with other people so they can get benefit from this as well. And please subscribe to this channel if you have not already done so. I'll see you in the next one. Till then, tata, bye bye, and do not forget to delete your cluster. All right, see you in the next one.